Review sheet D. Find the gradient. We're not given a particular value of x, so at this point it just wants us to find the gradient function. Find that by differentiating. So dy dx equals 60 x squared plus 26x minus 11, and the plus 5 disappears. The second question says find the value of this gradient when x equals 2. We use our answer that we found here in part 1 and we substitute in x equals 2. So for the gradient where x equals 2, I have 60 times by 2 squared plus 26 times 2 minus 11. If I then work out these individual parts, 60 times 4 gives me 240, plus 26 times 2 is 52, take away 11, gives me an answer of 281. So the gradient of this function when x is 2 is 281. Question 3 says find the stationary point. The stationary point happens when the gradient is 0. So I need to use my answer here from 1. So dy dx equals 60 x squared plus 26 x minus 11 gradient, and I want that to equal 0. Remember, you need to include the dy dx equal to 0 in order to get the mark in the exam. Now there's a clue in the question. It says to 3 significant figures, so we're not going to be able to factorise it. So let's use the silver calculator in order to answer this. So with my silver calculator, mode 5 for equation, 3 for a quadratic. My a value is 60, is equals to input that, 26 for my b value, and the c value is minus 11. My first solution then, press SD to write that as a decimal, and the question says to 3 significant figures. So to 3 significant figures, 3 digits that aren't 0 at the start or the end, my first solution is 0.263. Press again for my second solution, as a decimal. The second solution is minus 0.697, both to 3 significant figures. Question 4 wants us to find d squared y dx squared. So for this I need dy dx, which I found earlier. With dy dx then I'm going to differentiate for a second time. So d squared y dx squared 120x plus 26. Question 5. Determine which stationary point is the maximum. I use d squared y dx squared second derivative to determine whether it's a maximum or a minimum point. And what I'm going to do is substitute in the 2 values of x that I found earlier. So x equals 0.263 to start with, to 3 significant figures. And if I substitute that into d squared y dx squared, get 120 times by 0.263 plus 26. This gives me 57.56. But all I really need to be looking at is the fact that this is a positive value. So because it's a positive value, I know that at x equals 0.263, I have a local minimum point. I'm going to substitute in the second value, x equals minus 0.697, which I'm now expecting is going to give me a negative value, so I know it's the maximum point. D squared y dx squared, 120 times by minus 0.697 plus 26 gives me minus 57.64. So this time I've got a negative value as my solution, so I know that x at minus 0.697 is the maximum point. The final question on this review sheet wants to know the y value at the minimum point. So from the last part we found that the x value was minus 0.697. No, we didn't. This was at the maximum point. It was actually x is 0.263 at the minimum point. So it's this value, this second value, that I'm going to substitute in to the original equation to find out the y value at that point. So there's the equation given in the question. So y at the minimum point will be 20 times by 0.263 cubed plus 13 times by 0.263 squared minus 11 times by 0.263 plus 5. Working that out gives me a y value to three significant figures of 3.37.